In this lecture, we will discuss about some examples of a subset of a vector space, which is not a vector subspace. Let us take the example number 1. Check whether W is equal to xy such that x square equal to y square, where V is equal to R square is a subspace of the respective real vector space V with the standard operation or not. W will be vector subspace of V if the following properties are satisfied. Property number 1, W is non-empty. So clearly here, since xy are real number, so 0, 0 may be the element of W. So it satisfies the first property. If we go to the second property, closure under addition. So this property says that if we take two elements of W and if we add them, the addition should be also the element of W. So now let us try to disprove that this will not satisfy the second property. So we are taking two different element of W. One is 2 minus 2 because 2 square is equal to minus 2 square, which is equal to 4. So both are equal. Similarly, 5 square equal to 5 square equal to 25. So both the elements are element of W. Now let us add both the element and check that the addition is also the element of W or not. 2 minus 2 plus 5, 5. If we add then 2 plus 5 minus 2 plus 5, 2 plus 5 is equal to 7 and minus 2 plus 5 is equal to 3. The addition of these two vectors is 7, 3, and clearly 7 square is equal to 49 and 3 square is equal to 9. Both are not equal. Therefore, the element 7, 3 is not the element of W. So clearly here, we have taken two different element of W, which are element of W, but their addition, which is 7, 3, is not element of W. Hence, W is not a vector subspace of vector space V. Let us take one more example. Check whether W is equal to xy such that xy greater than or equal to 0 of vector space V equal to R square is subspace of the respective real vector space V with the standard operation or not. Again here we have to check that the W satisfy the following properties. We know that there are three properties. First property is W should be non-empty. Second property, W is closed under vector addition. And third property is W is closed under scalar multiplication. So clearly here xy are real number. So xy may be 0, 0. Therefore, 0 vector belongs to W. So first condition is satisfied by the given set W. Let us take the another condition, closure under addition. Let us take two element x and y of W. Now we will add them, and after addition, if the element is also the element of W, then we say that then the second property also hold. Let us take two element minus 3, minus 2, 1, 5. Because minus 3 into minus 2, minus 3 into minus 2, which is equal to 6, which is greater than 0. Similarly, 1 into 5, which is equal to 5, which is also greater than 0. Means minus 3, 2 and 1, 5 both are element of W. Let us add both the element. Minus 3 minus 2 plus 1, 5 minus 3 plus 1 minus 2 plus 5 minus 3 plus 1 is equal to minus 2 minus 2 plus 5 equal to plus 3. If we multiply minus 2 into 3, we are getting -6, which is less than 0. Therefore, -2, 3 is not element of W. Since -3, -2 and 1, 5 both are element of W, but their addition is not the element of W. Hence, W is not a vector subspace of V. Thank you.